Bismillahirrahmanirrahim. Assalamu alaikum. Today I will teach you something about mole. This topic is considered to be difficult by some students, but I hope after watching this video, their problem will be removed. So the simple introduction of the mole, it is the SI unit that is used to measure the amount of a chemical substance. It means it is used to measure the amount of atom molecules or ions, as we are using different units to measure the different physical quantities like meter, kilometer are used to measure distance, second, minutes and hours are used to measure time, milliliter and the liter are used to measure volume. So by definition, the mass of the substance containing the same number of fundamental units as there are atoms in exactly 12 gram of carbon-12 isotope. Fundamental units mean it may be atoms, molecules, or the formula unit mean ions. It depends upon the substance that involved. And mole, it basically relates the number of the particles of substance to the mass of the particle of that substance. It means it shows the relationship between these two things, number of the particles and the mass of the particles. As we have discussed, it is the SI unit that is used to measure the chemical substances. So one atom is equal to 1 mole. One atom contains 1 mole. For example, if we have one sodium atom, it contains 1 mole of sodium atom. If we have one molecule, it also contains 1 mole. It means one molecule is equal to 1 mole. Like one molecule of ammonia, it is equal to 1 mole of ammonia. If we have ion, one ion, it is also equal to 1 mole. Like one chloride ion, it is equal to 1 mole of chloride ion. Symbolically, mole is represented by MOL, mole. So 1 mole is equal to some specific number of the particles. These we cannot count these numbers, but we can only estimate it. 1 mole contains 6.022 into 10 raised to the power 23 particles. As 1 dozen of the egg contains 12 eggs, 1 paper ring contains 500 papers. Similarly, 1 mole of any material, any substance is equal to 6.022 into 10 raised to the power 23 particles. These number, that is 6.022 into 10 raised to the power 23, this number is called Avogadro's number, as this number is introduced by the scientist Avogadro. So 1 mole of sodium, it contains 6.022 into 10 raised to the power 23 particles. 1 mole of ammonia, it also contains 6.022 into 10 raised to the power 23 particles, and same is the case with the 1 mole of chloride ion. It also contains 6.022 into 10 raised to the power 23 particles. Now this is a problem. How it is possible that 1 mole of atom, 1 mole of molecule and 1 mole of ion, all they contain same number of the particles? We will solve this problem in our next slide. Now we are using another term that is called molar mass. The mass of 1 mole is called molar mass, and it is measured in gram. It means as a unit that is used to measure the mass of 1 mole is gram. Now this calculation of the Avogadro number, how can we calculate these 6.022 into 10 raised to the power 23 particles that they are present in every chemical substance? We are using this expression, number of the particle is equal to mass of the 1 mole of the substance divided by mass of 1 molecule of the substance. We will use this expression in case of ammonia. If we have 1 mole of ammonia, then how many Avogadro's number are there in 1 mole of ammonia? So put the mass of 1 mole of ammonia, that is 17 gram, divided by mass of 1 molecule of ammonia, it is 17. Here I am using 1.66 into 10 raised to the power minus 24 gram. This is the mass of 1 hydrogen atom. As this ammonia, it is 17 times heavier than the 1 hydrogen atom. So we will use this mass of hydrogen here. So after multiplication and simplification, we will get the answer, that is 6.022 into 10 raised to the power 23 particles of ammonia. So it is proved. You can use this expression to find the Avogadro's number in any substance, either it is 1 mole of atom, 1 mole of molecule, or 1 mole of ion. I think now the mole topic will become simpler. And don't forget to like the video and keep watching my channel.